All right, calculants, here we are. We're going to talk more about differentiability and some table problems. So I'm just going to, today is going to be more about like how do we solve problems and how do we think through problems with tables with differentiable functions. So let's go back to some things that are going to seem somewhat basic, but we'll say if f prime of x is greater than 0, that means that f has a positive slope. But it also means if you have a positive slope, right, you're going up. As you go over to the right, you're going up. So we call that f is increasing. Conversely, if you have a negative derivative, so if your f prime of x is a negative number, f has a negative slope. And your function f of x is decreasing. Right, if you have a negative second derivative, negative first derivative. Wow, sorry, your slope is downwards, you're decreasing. Okay, so let me give you an example of a table problem because we're going to look at a couple of these today. So let's say f is a differentiable function. And remember, that means it's continuous and the derivative always exists. Okay, so I'll write that down. F is continuous, and then f prime exists everywhere. Okay, so keeping that in mind, here are the values of the table. So here's x, here's f. X will go 0, 1, 3, 5, and then negative 5, negative 4, negative 1, and negative 2. Okay, so the first part of this question, it's a two-parter. I'm going to ask you to do this. I'm going to ask you to estimate f prime of 4. Okay, now you might look at this and be like, bruh, that's impossible. 4 is not in our table. 4 is somewhere in between 2 points that we know about. So what we're going to do is we're going to estimate the slope between the points on either side. So I don't know what's happening at 4, but I know what's happening on either side, so I can estimate it by finding a slope between those two. So f prime of 4 is approximately f of 5 minus f of 3 over 5 minus 3. And again, I chose 3 and 5 because 4 is in between those. I did not write between very nicely. So f prime of 4 is approximately negative 2 minus negative 1 over 5 minus 3. So that's negative 1/2. Now again, this is just an approximation. We have no real clue what the value is, but this is the best guess we can do, is just picking between the points on either side. Okay, now part B of this problem. Is it possible that f prime of x is greater than 0 for all x on the interval from 0 to 5? Okay, so that would mean you have a positive slope for all x. Now, we don't know what's going on for sure, so we're just going to try and say, okay, we have these four points giving us 3 intervals. So what I'm going to do is I'm going to estimate the slope on each interval. So I'm going to kind of find the average slope and ask myself, is there a positive slope? Is my f of x always increasing? And you might look at this immediately and say, okay, well, it's going up and then it goes down at the end. So the answer is no, because it's not always increasing, thinking about what we started with. But it's a good idea to look at these and say, okay, I'm going to find the average slope from 0 to 1. I'm going to find the average slope from 1 to 3. And I'm going to find the average slope again from 3 to 5. Okay, so average slope from 0 to 1 is f of 1 minus f of 0 over 1 minus 0, which in this case is negative 1 over 1 or negative 1. Okay, sorry, I am really stupid. Positive 1 over 1, which is possible. Okay, the average slope from 1 to 3. So that's f of 3 minus f of 1 over 3 minus 1. So that goes up 3 over 2, so it's positive 3/2. What about from 3 to 5? Well, that average slope would be f of 5 minus f of 3 over 5 minus 3, which is negative 2 minus 1 over 5 minus 3. So that's going to be negative 1/2. Okay. So the question asks us, is it possible that we always have a positive slope? Well, the answer is no. My average slope is negative on the interval 3 to 5, so it's not possible. And you can actually use the mean value theorem here. You don't have to cite it, but because the average slope is negative on that interval, there has to be some point somewhere between 3 to 5 that has a slope of negative 1/2, meaning we have at least one slope there. Okay, so that's how you do this problem. Just look at the average slope between the intervals. That's something that's actually pretty useful. So one other thing worth talking about. We got that my average slope on the interval to 0 to 1, the average slope on 0 to 1 was 1. Does that tell us anything at all about the slopes on the individual points between 0 to 1? Like, is f prime always 1 for all points on the interval 0 to 1? And of course, the answer to that is no. We don't want to make any assumptions about what's going on at those other points. All we know is the average slope is 1. Maybe it may not even be positive the whole time. It might be positive, then negative, then positive. We're not sure. Okay, so that's just something worth knowing about. Let's talk about the second derivative then. Okay, so here's what we were just talking about. We're going to go back to the start of this, because what we said is that if your f prime is positive, that meant that f is increasing. If your f prime is negative, you don't have to write this down again because you obviously did above, your f is decreasing. Okay, so let's go to the second derivative, right? We know that the second derivative is the derivative of the first derivative, or the slope of the first derivative. So if your second derivative is positive, that means that your first derivative is increasing. All I'm doing right here is the exact same logic from here, the above statement, and just replacing f with f prime. So f prime is increasing when f prime's derivative is positive. Okay, so what that means is that the slope of f is increasing. If you take this one step further and look at the negative, if f double prime is negative, that means f prime is decreasing, which means the slope of f is decreasing. Okay, so if I give you, for example, this problem. So I'm going to tell you, here's x, here's f, and I'm just going to give you 3 points. 0, 3, 5, -2, -5, -6. Okay, and I'm going to tell you, f is twice differentiable. And by the way, when you read the phrase twice differentiable, don't freak out about that. All it means is that f prime and f double prime exists. So the first and second derivative both exist. Okay, so f is twice differentiable. Is it possible that f prime of x is less than 0 and f double prime of x is greater than 0 on the interval from 0 to 5? Okay, so let's break these down. What does this mean? So f prime means your slope is negative. If your f double prime is positive, that means f prime is increasing. So we would interpret that as my slope is increasing. So again, what I'm going to do is I'm going to do the same strategy as the last one. So I'm going to find the slopes between points. And then I'm going to ask myself, is it negative? And is it increasing? Okay, so when I find the average slope on the interval 0 to 3, and then I'm going to find the average slope on the interval from 3 to 5. So I'm just going to look at this and say, okay, take the average slope there. So that average slope is -5 minus -2 over 3. So I ended up getting -1. Okay. The average slope on 3 to 5, let's look at that. So we'll get -6 minus -5 over 5 minus 3. So I will get -1/2. Okay, so let's ask myself, are these slopes negative? Yes. Are these slopes increasing? Yeah, right? Well, -1/2 is bigger than -1. So these slopes are negative and increasing. So, yes. So that's how you should be thinking about the second derivative of these table problems. It's kind of looking at the change in the slopes, right? Are these slopes increasing or are they decreasing? Right here, they're getting more positive. So anyway, that's how you do that problem. I hope this helped, and good luck on your homework. Bring some questions to class. I'll see you guys soon.